Every single day, millions of tiny decisions happen around us. Picking an outfit, choosing a password, or even shuffling a deck of cards. But what if I tell you that hidden beneath every choice is a secret universe of possibilities? Welcome to Combinatorics, the math that counts the number of ways things happen. Combinatorics is the branch of mathematics dealing with the study of finite or countable discrete structures. It includes the enumeration or counting of objects having certain properties. Imagine walking to your favorite fast food shop and ordering mix and match. At first glance, this seems simple. Just pick one main and one side dish, then pay the fixed price. Easy. But when we start counting the ways in which we can mix and match the options, we discover that the number of possible orders we can make grows fast. This is the fundamental counting principle. The fundamental principle of counting is a basic concept used to determine the total number of possible outcomes in a situation where there are multiple independent events. It states that when there are m ways to do one thing and n ways to do another, then there are m times n ways of doing both. Going back to our menu for the mix and match, how many ways can we make our order? If we pick one of the main dish, for example the burger steak, we now have 5 options for our side dish. We may order burger steak and fries, or maybe pair our burger steak with a peach mango pie, or a chocolate sundae, maybe even a Coke float or pineapple juice. And the same is true if we choose the other main dishes. For every main dish, we can pair it with 5 side dish. So we can say that since we have 3 main dishes, then we have 5 pairs of order, or simply 3 multiplied by 5. So the number of ways we can order mix and match is 15. Another example is picking out an outfit. But if you have to choose between either wearing a white or black shirt, then pairing with denim pants, brown pants, or a gray pants, how many ways can you pair your outfit? That's easy. Simply multiply your option for shirts, which is 2, and your options for pants, which is 3. So you can make 6 different outfits with 2 shirts and 3 pants. But real life isn't always step 1, step 2, step 3. Not all choices happen in order. Like being in a buffet and you're holding a bowl of ice cream trying to pick your toppings. You don't choose just one ice cream and one topping. No, you just scoop everything you want. Now that makes counting a little trickier, but we can make sense of it. Permutation, when order matters. Imagine watching a beauty pageant and you're ranking the remaining top 3 contestants. How many ways can you rank them? As you can see, when choosing one contestant as your champion, you will be left with lesser options for your runner-ups. For example, if you pick Philippines as your champion, then as your first runner-up, you may only put 2 options, which are Venezuela or Mexico. To put this into numbers, first you have 3 options, and after choosing your champion, you can only choose from the remaining 2, then the last one. So the number of ways you can rank the top 3 contestant is 3 times 2 times 1, or 3 factorial, which is equal to 6. Yet, sometimes, we put rules. From our example, what if the answer of Mexico is subpar and not worthy to win? Then we may not consider her as the champion. These rules reduces the number of possibilities because then the Mexico is not an option to be the champion, making the only possible option to 2. Every rule that we place reduces the number of ways we can rank the remaining candidates. But we don't need formulas for this. We just have to think if this make our list of options fewer. If yes, then our outcomes are also fewer. But sometimes the order doesn't matter. Like placing a bet in a lottery, you don't have to pick your first number, you just pick 6. Or when making a mixed smoothie, it doesn't matter what you put first since it will all be mixed anyway. Whether you put the ice first, or the milk, or the fruit, the outcome will be the same. If the order does not matter, then this is called combination. Combination, when order does not matter. Example, you are trying to pick out ice cream toppings. It doesn't matter what you put first, since it will all be mixed and be eaten by you eventually. So let's answer the question. How many topping combinations are possible if you can choose 2 out of the 5 toppings in the ice cream bar? First, we need to find the total ways to pair the toppings. Since we have 5 options for the first topping and 4 on the second, we can make 20 pairs. But since these pairs appears twice, we divide it by 2. And we can only have 10 combinations of toppings. In mathematical form, you may use this formula. Combinatorics is a math of choices. It helps us see how quickly possibilities grow, even when options seem small. From daily decisions to digital systems, it reveals the hidden structure behind all the choices we make.